Hi everyone, this is Serhan Guner. Today I'm recording a video for you from my office. So I'm going to continue the coverage. We started covering rigid body equilibrium in 2 dimensions, so I have some nice questions for you. Two force members, there's going to be only two forces, typically applied at the ends, and for equilibrium they have to be equal to each other as well. So I'm going to give a few examples. They are the same actually. I mean, they would look a little different, but they are the same concept. So let's say you have a single bar element and it is subjected to two end forces. It could be tension or compression. So let's say this is FB, this is FA, right? And A and B. So of course, if you call this F, it's equal to each other. It's something like that, right? Also, the members do not need to be straight. It could be somewhat curved like this, right? And in this situation, for equilibrium, let's make this compression in this case to have some variability. So FB equal to F. This is FA equal to F again. So this is A, this is B. And the final example on this, the member could be something like that. It's possible. It is also possible. So again, for equilibrium, what needs to happen, the two forces, you can go with tension or compression, it doesn't matter. So let's make this FA equal to F, FB equal to F. These are all two force members. Only two forces applied. There is nothing applied in between to these members. And what happens? The force is aligned. The force is aligned with the member. If it's a curved member, it's connect the two ends and see the force should be aligned with that, right? So this is, you might ask, how come this is a shortcut? If you don't see this, you might think there are two unknowns at each end, right? So let's say you are given a problem, and in the problem there is a, there are multiple members. So it is, something going on at this end, something else going on at this end as well. So if you realize, oh, this is a two force member, then you only have one unknown, right? So the force would be, let's say, aligned this way, and you can easily do calculate the components. So this is not writing properly, so I'm going to use black. So you can calculate these components. Let's say this angle is alpha, right? So if that's alpha, this is similar angle, that is going to be alpha. So this is going to be F times cosine alpha, F times sine alpha, right? If this is F, this is going to be only one unknown. So that is what it is. And in some questions, if you don't notice this and if you tackle with two unknowns, you may not be able to solve it because you only have three equilibrium equations. And if you create an unnecessary unknown, you might end up with four unknowns, and it's going to be not possible to solve it with only three equations. So only one unknown. So that is the benefit of two force members. and the resultant will always be aligned in this manner, which as I'm showing you in this example, right? Let's do an example. This is, I think, an aircraft wheel. So let's use a template. Determine the reaction at C and the forcing member AB. Right, so a little complex looking problem, but it's not as bad as it looks. If you know how to identify two force members. If you don't know it, you're in trouble, because I don't think you can solve this problem without identifying that two force member, right? So again, we need a strategy. We need to count how many unknowns to be able to solve this problem. And as you know, the maximum number of unknowns will be 3. Anything more, we won't be able to solve it, because that's the statics. 3 equilibrium equations. So if you look, there are 2 pins, and you would count that there are 4 support reactions. So 4 unknowns, not solvable, right? So there has to be some trick, there has to be some simplifications. And if you look at this, AB is a two force member, so you should be able to identify it with a quick look, because there are 2 members. One is this, call this DAC, right? This cannot be a two force member, because there are forces applied at 3 locations. There are, reaction force and reaction, the same concept. Reaction here, force here, so it's not a two force member. But AB is only forces going to be applied at 2 ends. This is a reaction force, this is an internal force. So yes, AB is, you need to notice or realize. Nobody will tell you this, but you should be able to realize this AB is a two force member. So based on these 2 unknowns at point C, 1 unknown at point B, and the resultant reaction would be aligned with the member. So that's a super good knowledge to be able to solve this problem. First of all, of course, I would need a free body diagram. Make it as simple as possible, no need to show the wheel. So just show it like this. I'm just going to exaggerate this a little bit. I'm just separating this a bit more because we need space for writing. Something like this. All right, that is good. Point C, definitely we are going to have 2 unknowns, right? So let's show it like this. This is going to be only 1 unknown, right? And it is very likely going to be this way. Okay, so you can call this B, and then this is, it's going to be probably in this direction, but we'll see. Not a mistake if your assumption is not correct. So it looks like what I have chosen before is CY, something like that. That's what I have chosen. So 2 unknowns there, 1 unknown here. So here two components, and this is, it looks like this angle I labeled it as 50 degree, right? So if this is 50, so you need to use trigonometry to get those angles like this. And this one, I see this angle is 20 degree. That is 20 degree. That's going to be needed when we try to figure out the resultant, right? So here, call this b times cosine 50, and this is going to be b sine 50, right? So we can label these this way. That is it, pretty much. That is that. We need to show the forces. So we don't have any unknown because it's given on this end. We are fortunate, otherwise again we wouldn't be able to solve this problem. 2 kilonewtons, this is going to be 6 kilonewtons, like that. So can I write horizontal equilibrium? Yes, but two unknowns. Vertical equilibrium, two unknowns. So I'm seeing that I have to take moment. So the beginning would involve taking moment. Typically, you take moment about a point to eliminate some of the unknowns. You can definitely, it doesn't really matter. You can take it about point C or point B, right? Because it's going to automatically eliminate three forces. This is going to pass through as well as those two will pass through. So let's just move with B, but when you are solving it, feel free to move on to moment C. That's also going to work out nicely. Summation of moment about B is going to be 0, right? Again, remind yourself counterclockwise moment or rotation positive. Taking about B, Cx will not create any moment. We have Cy, which is a positive moment, right? We have this 2 kilonewton, which is also going to be a positive moment. 6 would be a negative moment on the opposite side. So in terms of the distance, I'm feeling something is in terms of dimension. Are we missing any dimension? Let me just look into that, because you need the distance between C and B, right? So you need that distance. We know this angle, which is 30 degree. Distance between C and B is calculated using trigonometry as 331 meters. So that is the distance which I'm going to use. Alright, so let's start with positives. Cy times 0.331 distance. I mean, you see the importance of math and physics in engineering, so it's always coming up in any given opportunity. 2 times, you need the vertical distance for up to that point, that's the perpendicular. That's 1.0 meters. This is that, right? And then minus 6 times, then you have to look at the horizontal distance, and again using angles, that is 0.695. 0.695. That is distance from this distance. So that is the moment equilibrium, and then from this you would find Cy to be 6.56 kilonewtons. Let's do Fy equal to 0, right? So if we do that, 6 kilonewton up positive, um, nothing else, minus cy, which we know it, just plug that in, and minus b cosine 50 should be equal to 0, right? So if you do that, b will come out to be minus 0.871 kilonewtons, right? So minus means it is in the opposite direction. So you can fix this. You don't want to leave it minus, but invert the direction in your solution. So B is going to be this direction, and you can also show the angle. This is 40 degree. Right, if above is 50, it has to be 40 degrees, so this is B, something like that. So pretty much done, right? Reactions at C and the force in member AB. So the only thing which is remaining, no escape from that, we are going to do fx equal to 0, fx equal to 0. So what's going on with fx? We are going to get that cx. So in fx, 2 positive, anything else positive. This is going to be positive. If we invert this, this is going to be positive. B sine 50, it is going to be positive, minus cx equal to 0. So cx would be 2 plus 0.871 times sine 50. It's going to be 2.67. So this is reaction, this is reaction, this is force in B. Determine the reaction at C. So we did that. Yeah, that's it. These are answers. In terms of significant figures, maybe get rid of this one. That should be more than good enough. Okay. So that is it. Final question. Let's do one more. Determine all support reactions. All right, so again, before you dive into the question, you should really look how many unknowns. If you look 2 pins, it's going to give you 4 unknowns. 4 unknowns is a no-go. We cannot solve it. We have only 3 equilibrium equations, so there has to be some shortcut, some trick, and it's obvious in this case DC is a 2-force member because it's subjected to forces or reactions at both ends. There is only one unknown here, so it's very similar to the previous question. Geometry is a little bit simpler. Previous one had both 2 angles, so I would see this as the simplified version. Reactions would be something like that. So if you identify these, it's a really good start to get this problem solved. Of course, as we always do, need a good free body diagram. So I'm going to sketch it here. And I think this is going to be up, right? This has to be this way and this has to be that way. So if you make logical assumptions, it might be a little easier for you to see it. So these are the directions which I'm assuming. This is AY, AX, call this D. Only one unknown, so I have 3 unknowns on this system. This is A, C, B, and this is point D. Definitely we would need angles. The angles would be needed. Let's just get some calculated. This is a triangle, 3, 4, 5 triangle. If you calculate this angle, you would find it to be 53.13 degree, and that is the same as this angle, because sooner or later we would need force components. As you know, adjacent is always cosine. D cosine 53.13, and then this is going to be D sine 53.13. If there was a self weight, I was going to put it at the centroid, so C is at the midpoint. You would put another arrow, dead load, self weight, and another one from this midpoint going down, but luckily we don't have those, and solution would be slightly easier. Yeah, I think that's it. Again, very similar to the previous question. If you do vertical equilibrium, two unknowns, you cannot go, it doesn't give you any unknown, two unknowns. If you do horizontal equilibrium, again, you cannot find, you would find AX equal to D sine 53. So again, you have to take a moment about what point, doesn't matter. Again, because the supports are aligned, if you take it about point A, you will eliminate three forces. Three force extensions will pass through point A, will not create any moment. It's going to be AX, AY, as well as D cosine 53. It would pass through A. The only unknown in the equation would be D sine 53. That would give you the solution. That would be cool. If you take it about D, it's the same story. Then you are eliminating D as well as AY. You would find AX. So it doesn't really matter. But only two options. Take it about A or D. Nothing else will work for this question. Summation of moment around point A. Set it equal to 0. Counterclockwise, positive. So which one is rotating positive? Definitely this is negative, right? This is positive. Okay, so D sine, let's start with this one. D sine 53.13, that's rotating counterclockwise, nothing else, it's only this one, times the distance 3 meters, perpendicular distance, that is it, minus 5 times distance 8 meters. Only two forces, huh? Yeah, that is it, equal to 0. And then based on this, you would immediately find D to be 16.667 kilonewtons. Luckily, what we assumed was right. It came out to be positive. So this is the direction. Call it 37. We are not going to use it in the solution, but this is just for the answer. 37 degree, which is cool. So question is done pretty much. If I do horizontal, I'm going to get AX. Which is positive. This is positive. D sine. It's again the same term. Yeah, see, we are using the same term again. 313. That is positive. Minus AX equal to 0. And then from this, AX will come out to be 13.334. And again, it's positive. Luckily, what we assumed was right. I'm showing the orientation, the direction of it. Finally, Fy. So D, now we are using the cosine. D cosine plus AY minus 5 equal to 0. So based on this, AY will come out to be, AY is coming to be minus 5 kilonewton, meaning that the direction is not right. It should be going down. Let's fix that. So I'm fixing it. AY 5.0 kilonewton. This is my final answer, and AY is going to be going down. So you can always, in your final answer, you can fix the assumption. I mean, the beginning it was just an assumption, but it ended up being this way. We can get rid of two decimals. 13.3 is good as the final answer. This is 5 kilonewton final answer, and this is 16.7 is good for the final answer. So it's done. All support reactions nicely done. You will see more solved examples. If you are looking for examples, for example, you can solve this one, 5.5. It's a pretty cool question, very similar to what we have done. Neglect the weight, determine the horizontal and vertical components of the reaction. Right, so this is a roller, this is a pin, so 3 reactions, no problem with it. Some triangular laws in this problem, you can solve it. There's a moment also applied. This is very similar to what I have done in class. You have a similar one. This looks a cool question. You can also look at that. This is similar to the aircraft question which I solved, very similar. I mean, this is tension, it's only one unknown with the tension cable, that is similar. This is another one similar to what I have solved. And here you will see 2 force members. It's covered here. You can look at the narrative for 2 force members. Mechanical engineers, you would be dealing with machines, and I can immediately tell you that BD is a 2 force member, right? So if you connect these points, the resultant will pass through CFF. That's how you solve this. Otherwise, you won't be able to solve because there is going to be 4 unknowns. Very critical. I mean, you shouldn't be missing any 2 force members. All right, so that's pretty much it, everyone. Thanks very much for your attention, and I will see you next class. Okay, bye-bye. Take care.